In this video, I will consider one numerical on source transformation. Find the voltage across the capacitor of 20 ohm reactance of the network shown below using source transformation. This is the given network. We need to find voltage across this minus J20 ohm reactance. That is VC we have to calculate. So this is the circuit we need to calculate VC, that is voltage across J20 reactance using source transformation. Here we can observe that J2 amp is in parallel with J15. Similarly here J1 is in parallel with the reactance minus J5. We can convert this current source into voltage source as well as this current source into voltage source. That is, convert these two are in parallel. We can convert current source to voltage source. So we know that V equal to IR. So I value is, so we know that V equal to IR, that is V equal to I is J2, R is nothing but reactance here, it is J15, or we can write 2 into 15 is 30, J into J is J square, that is V is equal to J square means minus 1, that is minus 30 volt. Similarly, I can convert this current source into voltage source. V equal to IR, V equal to I is J1 into R is minus J5, that is V equal to J into J minus J is minus J square, 1 into 5 is 5, that is V equal to J square means minus 1, this is minus, that is plus 5 volt. So this current source is replaced by 5 volt. Now let me draw the equivalent circuit. Here we have current source is replaced by 30 volt. So this is minus 30 volt. Polarity is head end is this side. So this will be positive, negative. So this J15 will come in series with this. This is J15. This J5 is kept as it is in series, that is J5. This will be kept as it is in parallel, minus J20. Here 20 volt source is kept as it is, minus plus 20 volt. So here this minus J5 will come in series. This is minus J5 and current source is replaced by voltage source. So this end is head. So it will be positive, negative, that is 5 volt. So this is the reduced circuit. So further here we can observe that these two are in series and these two voltage sources are in series. Let me simplify this further. So I can write minus 30 as it is. So here J15 and J5 are in series. I can add them and make it J20 ohm. This I will keep as it is. So this is minus J20 kept as it is. Here voltage source and this voltage source are in series. I can replace these two voltage source by single voltage source. Minus plus, plus minus. Opposite polarity, we have to take the difference. That is, difference between this voltage and this voltage is 15 volt. And we have to give the polarity with respect to highest magnitude. So I can write plus minus 15 volt and this minus J5 is connected in series. This is minus J5 is connected in series. To reduce this further, now to reduce this further, I will here voltage source is in series with reactance. Here also voltage source is in series with reactance. I can convert this voltage source into current source, this voltage source into current source. That is, I equal to V by R. V is minus 30, R is J20. J20, that is I is equal to 1 upon J means minus J. That minus J and minus will be plus J. 30 by 20 is 1.5. Similarly here I can write I equal to V by R. V is 15, R is minus J5. That is I is equal to 1 upon J means minus 1. That minus and minus will be plus. That is plus J into 3. 15 by 5 is 3 amp. Now let me redraw the circuit. So this voltage source is replaced by current source. Let me draw here current source. So here this plus minus means head end should be here. So value is J.5. This J20 is connected in parallel to the current source. This is J20. This is kept as it is. This is minus J20 and this voltage source is replaced by J3. This is voltage source plus minus means down arrow. Value of this is J3. This J5 is connected in parallel to this, that is minus J5. Now further here we can observe that this current source and this current source are in parallel but opposite in direction. So we have to take the difference, that is 1.5 and 3. The difference is 1.5. So I can replace two current source by single current source of magnitude J 1.5, and we have to give rest all things I will keep as it is. So here we have J20, this is J20, and here we have minus J20 and here we have minus J5. It is minus J5. So now here we can observe that this J20 and minus J5 are in parallel. I can replace these two with equivalent value. That is equivalent value, that is J20 is parallel with minus J5. The equivalent value I can calculate as, so equivalent value I can calculate as J20 into minus J5, that is product of these two divided by sum of these two, J20 minus J5, or I can write these two are in parallel. Let me calculate the value of this. So now keep the calculator in complex mode, that is option 2, keep it in complex mode. J20 into minus J5, that is open the bracket, 20I into minus J5, that is minus 5I, that is if we give equal it will give the numerator value divided by, that is divided by, we have J20 minus J5 is 15I. So this is the result, that is minus 6.667I. Let me write the value of this is minus 6.667J. Let me redraw the circuit. Here we have current source of J 1.5 and here the equivalent value is minus J 6.667. This is kept as it is. This is minus J20 ohm. So in question it is given positive, negative, and this is VC. So now we have to find VC. To find VC, first we have to find current through this resistor. Let me find the current through this resistor. Here this current will flow and part of the current will flow here, part of the current will flow here. Let me call this as I. I will apply current division rule and I will calculate I. That is by applying current division rule, that is I is equal to total current, that is J 1.5 into opposite resistor. Here this is opposite resistor into minus J 6.667 divided by sum of these two, that is minus J 6.667 minus J20. That is, let me calculate this. Now on numerator, that is 1.5I into we have minus 667I is equal to this value divided by, we have minus J 6.667 minus J20 is minus 26.667, that is minus 26.667I. So the result will be this one, that is 0.375I. Let me write it as 0.375J. So this is the I. Now we have to calculate VC. So here we can observe that for this VC, this polarity is positive, this polarity is negative. But current is flowing like this. According to current, this polarity should be positive, this is negative. But VC is, this is positive, this is negative. Therefore, we can take it as, I can write VC is equal to, this will be minus because this end is positive, that is minus 0.375J into minus J20. Therefore, VC will be at, this is minus 0.375I we have into minus J20, that is minus 20I. So it gives minus 7.5 volts, that is the result is minus 7.5 volts. So this is the final voltage across given 20 ohm reactance. Thank you for watching.